Okay, so here's what we're going to be doing now. This is a very low res cloth made in MPM Bifrost and exported to the Unreal Engine. Because I know that you guys have a hard time with non-game related stuff, so this is the file that makes it. You can see it playback there. It's not the best cloth in the world, but it's really just a preview. So we're going to go ahead and start looking at cloth. So let's start with the PowerPoint, because that's where I started, and that's probably a good place to start, to be quite honest. So we'll start with MPM cloth, which starts on slide 26. I'm just going to save this. Oops, I'm going to save this and make ourselves a new file. We'll create the graph. So once again, because it's a Bifrost simulation system, it's done the same way. Let's put down a basic MPM cloth and explode that guy. There we go. Once more, you have your input. Now this is slightly different. This is your source here. This is your constraints. So you can constrain your cloth as well. We'll be going through that in just a second. Again, colliders and influences, solver settings, simulation engine, and again, we've got a surface material here as well. So let's just go ahead and follow the PowerPoint a little bit. We're going to make a mesh plane. So let's make a mesh plane. And always we'll put a terminal so we can see what we're doing. Plug that in. We've got a pretty boring standard plane. Let's make this guy 10 wide, 5 high. And let's go for 64 by 64 segments. No, even less, 32 by 32 segments. So the number of segments you put in here is going to, oh, why don't we have squares? 64 by 32, there you go. The number of segments you have here directly affects how fast or how slow the MPM goes, because it's got more things to work on. So this is going to become our source. And really, just to make that the source, we're just going to drop it straight into geometry. Now, if I press play now, or if I turn on the display of the diagnostic of the simulate MPM and press play now, it's going to do something like that. Not really what we want, not really working all that well. To sort this one out, we're going to need to constrain it. And what I want to do is constrain it at the corners. So imagine kind of a hammock, yeah? And I'm just going to quickly make some constraints. You can bring in meshes from Maya, you can build your own constraints the way you like, but the way it's done is with geometry. So let's put a sphere down. Let's make that quite small, say 0.25. It's fine, we can throw that into the terminal too. To have a look, put it in the proxy this time so we can keep it separate. There it is. Let's make it even smaller, 0.1. No, maybe 0.2. That's probably a good idea. And what I'm going to do is I'm going to put a sphere on each corner of this plane. Okay, now I know what my length and width of the plane is, so I really just need half of that. So if I put this to 5, oopsie daisy, 2.5 in the X and -5 in the Z, I'm going to get a point there. Then I can just duplicate that, paste it down, have that +5 there, pop that into the terminal as well, and I'll just do the other two really, really quickly. There we go. So we now have 4 spheres that we're going to use to hold the corners of our cloth. Let's build an array, just so it's easier to deal with them, and we'll just plug all 4 of them in, like that. And we're going to put that into our constraint geometry. Let's see what our cloth is doing now. I'm just going to turn off the diagnostic so we don't see our rectangle anymore. Go back to the beginning. So let's press play on this. And this is what we get with our defaults. Maybe we have a few more frames so you can see a bit more. So you can see it's behaving like cloth. And most importantly, it's constrained at the edges. Or at the corners rather, which is precisely what we wanted to do. I'm going to change a few things here. So let's set our start frame to 0 so that we have cloth when we reset. Press play. So obviously that's very, very stretchy cloth, and we're going to need to play with some of the settings to get that looking a bit better. So the first setting we're going to play with is area preservation. Well, okay, let's go through it because you need to know what everything does. You have mass density, which is simply quite how heavy the cloth is. So if I set that to 100 and replay that, the cloth will be a lot lighter. You can see it develops more of a wobble. There's more creases and such and folds in it. So that's the first thing. Viscosity. We're going to use the info here. How much motion of nearby points will be averaged out. Okay, so that's basically how smooth and fluid the motion is. Let's set that to 0. See what that does. So you're getting a lot more wobble and a lot more creasing going on, which is fine. Now the one we want to really talk about is area preservation. So this is basically how much the cloth preserves its shape. Okay, so if that's set to 0, let's set that to 0. So that'll be the no area preservation at all and the highest resistance to shape change. Whereas then if we set that all the way to 1 to get the opposite effect, rewind and play, you can see it's quite a major difference there. It kind of looks like some sort of alien, which is good. We like aliens. Rather, let's set this to fairly low, but not all the way low. Then we move on to vibration speed. In vibration speed, the speed at which vibrations travel through the cloth in meters per second. Basically, this is how stiff it is. So the value should be positive always, and larger values give stiffer results. This is the speed of sound in the cloth and the natural speed of pressure waves. Thing is too, if you turn this up, and this is one of the ones you might find yourself editing more and more and more, if I double this, then it's going to take longer to simulate the cloth. You can see it's a bit slower, but it's also a bit stiffer. It's not bouncing as high, getting it to settle faster, things like that. So what I find myself doing when I'm working with cloth is take a guess at this and then increase it by 10 each time until I get something that I'm liking the look of a bit more. And once you get it up over a certain amount, it starts to be a case of having to play blast it to get a real-time result from it. But something like that's pretty cool. Collision max speed. It's related to vibration speed. Very similar. Magnitude of the collision forces and use of units of meters per second. Should be positive, larger values get stiffer results. And again, the higher that goes, the slower things get. So if I set them both to 40, slightly faster, but it's also deforming and stretching a lot more. If I set the max speed up to 80, definitely a lot slower to simulate without too much results. If I say take that back to 40, take the vibration speed to a crazy level, to say 120, much slower to simulate, but it's giving me much more of the result that I'm wanting here. Adds stiffness to the cloth. So two very important settings there, vibration speed and collision max speed. Thickness is how thick the cloth is. So the cloth will behave differently when it's thick than when it's thin. This can be a bit subtle at times, but it has quite a big effect on the final output. Like so. Friction is how much friction the cloth has with itself and anything it's colliding with. Initial speed is how fast it's moving at the beginning. Direction is which direction it's going in. So if I was to set this to 1 and this to 1, so we should all move in this direction. Yep, and you can see it just moving slightly in that direction until the constraints catch it. If I push that, like really push that, you can overwhelm your constraints almost entirely. But you can see what it's done. Now it's bouncing back and slowly settling. Cool. That's kind of getting us to where we want to be. Inherit velocity. Again, if your source is moving, this will inherit that percentage, 0 to 1% of that velocity. You can try preserving your interior volume, which doesn't work very well when you have an initial speed of 10, but that's going to try and preserve the volume that's building the MPM. It's something that you can use, and that's how stiff the volume is, the target volume ratio. That's working pretty well, but it's now very, very stiff cloth. So we'll just turn that off. Tearing we're going to do soon. We'll come back to that. So some other things that are general MPM things that we have been looking at for the last 3 lessons. Let's just set this cloth up so it's a little faster again. So we'll take this sort of back down to 40 and this back down to 20. Maybe leave the thickness where it is. We're going to get faster computation speeds, but a lot stretchier cloth. And that's all right. We know what we're doing now. If we come down to the solver settings, you've got a lot of stuff you should be familiar with. You've got the enable solver, start frames, label point ID, label sources. Then you've got the resolution of the MPM solver globals, and this is just the same as what we were doing with sand and snow. If I set this detail size down, so it's a higher resolution, then it's going to calculate more detail for me. Detect discontinuity, link collided detail, they're the same as before. Cloth shell resolution is probably a little more important here. Use mesh resolution basically means if I'm bringing in a mesh at 64 by 32, then use 64 by 32. If I turn that off, I can then scale the detail size to say twice the size. Reset that. It's a lot slower, but it's using a higher resolution mesh to calculate. So there might be a situation where you need really, really intense detail and a low-res mesh, say, output to a game engine, and you might just want to wear the time it takes to do that. So we'll just turn that back on because it'll be a lot faster if you turn that on. And obviously detail size scale only works with when that use mesh resolution is turned off. Enable gravity, we should all know what gravity is like and about by now. Scene units in meters is how big is the scene. So what is each Maya unit being calculated as? 1 meter, 0.1 of a meter, that kind of thing. Speed of the simulation. And you've got 2 styles here. So automatic from sources, smooth or chunky. So let's have a look at smooth. It's the smooth style. And we're getting our bounce and things, and that's all cool. We'll go to chunky, take it back on. Not terribly much of a difference here. So I'm just going to leave that on automatic. Accuracy, how accurate the simulation is. Now, if I set this time step size down, it's going to calculate the movement in smaller steps. So the movement will be more accurate. Then you have minimum and maximum number of steps that you can do. Point display, we know what that is. That's basically just showing us the points. Maximum voxel movement, we can take a look at what that means, but I've never really touched it. Maximum voxel distance in voxels, that a particle can move before the simulation is considered to be becoming unstable and the frame is retired with a smaller, retried, sorry. The frame is retried with a smaller time step. So basically that says, if a voxel moves this much and it's more than that distance, more than the maximum, then the simulation goes, okay, this is getting unstable. I'm going to re-simulate that with a smaller time step so I can get more movement. This is for if you've got something that's moving very fast that you want to simulate, and it'll help with that. Max retries is the number of times it will retry, basically, in a time step. And lag colliders, I don't know. whether to lag the input colliders by 1 frame. When lagged, the geometry from the previous frame will be used to collide the simulation for this frame. This allows Simulate MPM to see what will happen with the collider and prevent overshooting. There you go. Again, that stuff, the advanced stuff seems to be all to do with something that's moving at speed. Then we had a look at the diagnostic properties before, so if I turn that off, turn that back on, we're going to get our points. It's going to show us our points. Come to the solver settings and display the volume, then it's going to show me the volume that it's working with to make the MPM cloth. Oh, I should have started that at 0 because it's just exploded. There we go. Let's go back. So you can see the volume there. You can see how the volume's simulating, how it's transferring its properties to the points, like we talked about at the beginning of the video. It's a really good example of that. And the rest of it is diagnostics. So I want to see those points as cubes. Now the cubes. That kind of thing. You know, how many, that's not all of the points that it's actually making, it's 1/10 of them. If I set that to 1, I'll reset the simulation. Well, it's going to do that. Let's go back to 0.1. You can change the seed. Simulate that again. Yeah. What color you want. Property sampling. Etc, etc, etc. Show you velocities, that kind of thing. Let's turn all that off for now and go back to our proxy view. Cool. So that is running through the settings of cloth. The important ones to take away that we're going to be looking at more is area preservation. So remember, if I go take that to 0.9, it's not going to try and preserve the shape of the cloth at all. It's just going to let it go where it'll go, which seems to involve stretching it into infinity. So 0.1 is a good startup for that. Gives you just a nice, you know, it's quite a high resistance against change of shape. Not so much that it goes bananas. You can make that a little smaller too, quite happily. So we can go, say, 0.25. Play that back. It's not going to hurt you too much, and it's going to try and keep the shape even more. So that's good. This will be the one that we work on the most to get. This one and vibration speed are the two I tend to work on to get the look I want. That's arbitrary, that's up to you, that depends on what cloth you're making. But we'll do more of that when we make the flag. So the next thing we can do is if I just pull this guy up here and get this terminal out of the way, and I didn't need to constrain. What I need is the cloth properties. So this is just all of these, but there's another one here that's not visible on the interface, which is reference point positions. If we take a look in here, so it should be defines the rest state of the cloth. Attach an array of positions to define the state in which the cloth is not stretched and uncompressed. Use this if you want your cloth to be initially stretched out. So now we're on slide 30 of the PowerPoint. If I was to take my plane here, and let's just turn off the proxy so we don't see the spheres. No, we'll see the spheres. Turn on the diagnostic. Go back to the beginning. If we take our plane, transform the points like this. And if you know how matrices work, you can just work in the matrix, or you can do an SRT to matrix like this. Plug that into the matrix, and let's just push the scale of this up a little bit. So you can see now that the plane that isn't scaled is still being the source for our cloth, but the plane that is scaled out here is bigger than our cloth. And what I'm going to do is get those point positions like that. I'm going to put it into a point scope so we can actually see them. We'll just hook that up to the point scope there, and we'll pop the point scope out. Like this, you can see the green dots are the points. Maybe we'll make those a little bit smaller, just to give us an idea. And I'm going to plug the point positions into the reference point positions here. And to show you what this does, I'm just going to switch gravity off for a minute. So if we come down to gravity, switch that off. And we'll just turn off the diagnostic. Oh, I'll plug this into the proxy so we can see what's going on. And turn the cloth back on. Not that one, that's the cloth points. We want the cloth mesh. Okay. So this is quite a lot bigger than the cloth. What happens when we play it now when its rest positions are big? It tries to stretch out to fit those positions. You see how that works? Now it can't because it's constrained in 4 corners. Suddenly you've got all of these wrinkles turning up where the cloth is trying to fit into this area and it can't. So that's just a way of getting something started. You can see it using all of its settings to try and push its way into that shape. Doesn't quite work. You can also go the other way. So if I set these to 0.9, so now you can see that it's smaller. Let's set our X back to 1, like that. So that it's just smaller on one axis there. Let's see what it's trying to do now. Again, it tries to stretch to that. So it's going to keep oscillating, but see it's trying to fit those rest positions. And again, actually I don't need to scale the Y, I really just need to scale the Z. We go outwards, and then you're starting to get ripples and folds and stuff like that. And eventually it'll settle. So that's what rest positions do, and they're really, really handy for doing that because it's a good way to get wrinkles really, really quickly. I mean, you could get silly, and it's always good to get silly just to really see what things do. Let's really stretch that out and see what the cloth tries to do. No, it's almost tearing itself apart to try and get there. So let's stop being silly and just slim that slightly bigger. And that's slide 30 basically. We'll talk about tearing now. In fact, let's do some. Basically, let's just set this back to 1:1. See what the cloth does. Nothing. It's already fit the shape. So this is just not having an effect right now, which is okay. And we will turn gravity back on. There we go. And I mean, we can see what it does if we have gravity turned on and this bigger. See what happens then. You see it trying to fit. It just lets you start with wrinkles, basically. But for the next one, we'll just set that to. Just like real cloth, if you want this cloth to tear, you're going to need to put some pressure on it. So what I'm going to do is I'm going to take 2 of these spheres and I'm going to animate them moving outwards. Which 2? Well, let's find out. Oops. Definitely that one. Not that one. And definitely that one. So it's these 2. Just move this out of the way. So I'm going to set up a really quick animation which these 2 just push away from each other. And I'll speed up the video, and you feel free to pause and copy it if you need to, but it's just something we've done several times before where we're just animating the motion of this. So here we go. So now you can see these 2 are slowly moving apart from each other. And they're still constraining the cloth at this point. So they're stretching the cloth out as they go. So it's exactly what we want. So now if we come to our tearing section, we can enable tearing. And you can see that we've got a little bit of a different view here. changes the way the mesh is built. I'm just going to switch off our point scope right now, just because that's getting in the way. Now what happens if I pull this out? So eventually it's going to get to the point where it bypasses the threshold of the cloth and it tears it. There it goes. And it's torn the corners out, as you can pretty see. Oh, and then that bypassed the threshold and it tore again and fell off. So we're going to need to fix that threshold, really. And of course, just like everything else we've done, we can do like the PowerPoint does. We can do basically a position-based setup by using a field. So let's put down a fractal noise field like this, and let's straight away let's just get a scalar field scope like that. We'll plug the field into there. We'll grab our mesh plane just for now, and we'll put that into the probe, and then let's just throw that straight into the diagnostic and take a look at it. So if we wanted to make sure we saw everything, we just need to take this guy and take him back to -1. You can see the various values. Blue is below 0, anything else is above 0. And these are the values that are being put into this field on here. We do an F-curve as well. F-curve field, that is, so that we can adjust it quite happily. So let's plug this in here. And then the whole thing, we take the whole result of that and we'll plug that into the tearing threshold. Like this. As I think about it, I'm going to turn off this for a sec. And let's kind of see what this does now. You can see tears happening where the tearing threshold is lowest. And then slowly and surely, as this pulls out and we pass the tearing threshold, it just tears itself apart. And it's quick and it's easy to do. So, oops, didn't want to play. Let's stop, please. Thank you. We'll go back to the beginning. And let's turn on our field. Let's just get our scope sorted out so things look a bit better. 0.05. So they're much smaller points. And then we can change some stuff in our field. Why don't we get smart and put the F-curve field out so we can see what's going on? We can change some stuff in our field here, like the frequency. What would be really good though is if we scale the field. So and all we're going to do here is scale it 10 times in the X. So you get bands. Let's put our frequency up some more, even more, maybe a little less. So you've got basically bands of weakness here. And let's see what happens if we play that. Maybe turn off the scope so we can see what we're doing. No, let's put that back on and go back to the beginning, and let's just play with the scale and the frequency a bit more. Try something like that. So we've got from, let's put that into a curve. Let's get that back to -1 and down to -1. So it's going from -1 to 1. So I think we need to be from 0. Let's double check. Tearing threshold. So the current edge length and the tearing threshold exceeds the referenced edge length. It's the product of the two. Let's turn off our scope. We might have actually set that up a bit easy. I have a feeling that if we bring this back to 0, I You can see what it's doing there. And quite quickly too. It's happily torn itself apart. Let's try and get a nicer field going, just to get a bit of a nicer look. So let's see what we get there. That's pretty much torn itself apart. And we're working on quite a low res cloth here, so the mesh isn't that high res, but you can see it's nicely just tearing great holes in itself, becoming ragged, pulling off its constraints, all that kind of good stuff. All right, so that's tearing. Like everything with simulation, it's the secret of simulation is mostly just you change settings until it looks right. And the more you change the settings until it looks right, the more you get used to what looks right and what doesn't. There's really no other way around it but to do lots of simulation. And it's the same with this. But that's a nice result. That's a good result there. It's nice and torn. I mean, it's very low res right now. We could, fix that by going over here and let's just double both of these. So 128 to 64, reset. Takes a little longer. You see it's much denser mesh now. If we play that, it's going to take longer to simulate. You might turn that off for now. But you're also getting higher res tears. Folds and tension and all sorts of nice stuff going on. And fairly quickly and fairly easily from a simulation engine as it just rips itself to pieces. Which is awesome. And the other thing that you can do, of course, is you can paint those weights on there. So your tearing threshold or your tearing weights don't have to come from a noise at all. That's looking lovely now. They don't have to come from a noise at all. They can come from a color set that you've brought in, or pretty much anything that will produce a scalar result you can use to apply to this. So that's the basics of it. Those are some of the attributes to tweak to get what you want, to get the look that you're after. It's how to do constraints, it's how to set up cloth. So the last thing we're going to do before we're done with MPM is I'm going to show you how to build a flag and bring it into the Unreal Engine. Because the secret is, on output, that is still a mesh. Now, a lot of this is going to be tied up with next week's lesson, which is USD, and the week after, which is also USD. But hey, might as well do it now. I'm not going to rebuild the flag. I'm going to use the file I already have, but I will take you through it. Okay? I'm going to let that play out and see what it looks like. And don't forget that these constraints are still moving apart. Seems like and what we have here is a wonderfully torn up, broken bit of cloth. So that's where I'm going to leave this. I'm going to pause this and then I'll come back with the flag file ready for you and we can talk about that.